So hello guys, this is another question from IIT JEE PYQ. The question is from the Advanced 2014 here. Advanced 2014. And here is the question. Consider an elliptically shaped rail PQ in the vertical plane with OP as 3 meter and OQ is given as 4 meter. A block of mass 1 kg is pulled along the rail P2Q with a force of 18 Newton, which is always parallel to the line joining this PQ. Okay, so this is the direction of force that is acting here on this block that is given, and the value of this force is what? F is equal to 18 Newton, right? Okay, so assume no frictional losses. The kinetic energy of the block when it reaches the Q point, that is n into 10 joules. We have to tell the value of n here. The value of n is what? We have to take the acceleration due to gravity. Acceleration due to gravity, that is equal to 10 meter per second square. So g will be here 10 meter per second square. Okay. Now first I will draw the free body diagram of this block, or what it block of mass m that we are taking along this rail. Then this is the free body diagram. Let us suppose mass of this block is m here, and what are the forces acting on this block is, one will be a mg force acting in downward, okay, and one force is acting always along this line joining pq, okay, that is I am calling f, okay, and one will be a normal force. That normal force will always be perpendicular to this rail. That is what? That is always perpendicular to this rail, and I am taking, right? Now since we have to tell the initial kinetic energy when this block started from here, from the point P, that will be 0. So K initial is here 0, and let us suppose the K final is the kinetic energy of this block when it reaches to point Q, right? So here we will be using the work energy theorem. That work energy theorem, what does the work energy theorem say? It says that work done by all the forces will be equal to change in the kinetic energy of this body, that is K final minus K initial. So here K final is not equal to 0. Here K initial is 0, so K final minus K initial, that is 0, is equal to work done by all the forces. That means there are three forces acting on this body. One is the W, work done by this mg force, plus work done by this force F, that is acting always along this line PQ, plus work done by this normal force. So this is what we have to find here, right? Now I will be coming to the definition of that work, mathematical definition. That work we are writing as the dot product of force and displacement vector, okay, and in magnitude form I can write F as cos theta. So here this F is the force, and this S cos theta is what? This S cos theta is the displacement of body along the line of force, okay. Now I am coming back to this diagram. Here you can see this work done by this mg force I will be calculating here. So what is the line of force of this mg? So for our block, mg is always acting, work done by this mg we are calculating here. So line of force is always along this y direction, that mg is always along in negative j cap direction, okay, that is negative j cap direction. So in taking this block from this point P to Q, there is a force acting in this direction, that is mg. right? Then what is the work done by this mg and what is the displacement of this body along this line? So our body is going in, what is the displacement of body in y direction? That is 4 meter. So here I will be writing displacement of body along y direction is 4 meter. Since displacement in upper direction and force is acting in downward direction, then work done by mg I will be writing, that is f s cos theta. So this s cos theta is the displacement of body along the line of force, that is along the line of force, but it is opposite to the line of force. That means there is 180-degree angle between them. So this work done will be negative, that is mg into 4 minus 4. So work done by mg will be equal to negative 4 mg joules. Okay, let me call it equation number 1. Right, now I will be calculating by this, by the work done by this force F. Work done by this force F. Now let me draw the diagram here. This is our rail, this is the point Pu and this is point Q. Okay, and this is our block here, and the force on this block is always acting on this, along this line joining PQ. Okay, and this side is given as 4 meter, this is 3 meter, right? So since work done we have been defined as W is equal to F S cos theta, and this S cos theta is the displacement of particle, displacement of body along the line of force. So here PQ, this is the line of force, and displacement of the body is also along this force, we have to, along this line of force we have to calculate. That will be equal to what? This line will be equal to under root 4 square plus 3 square. That will be equal to under root 25, that means 5 meter. Okay, so here force is equal to what is the value of force given in the question? That is 18 Newton. So here force is given as 18 Newton and displacement along the line of force is 5 meter we are getting. So work done by this force will be equal to 18 multiply 5, that is equal to what? 19 joules. So work done by this force, that is equal to 90 joules we are getting. So this is our equation number 2. Now coming to the another force that is acting on this body. So work done by normal force we will be calculating here. So this is our trail, this is our rail here, this is the point P and this is the point Q, right? Now since at every intermediate situation, at any time t, this body is moving a motion like this, and due to this rail there is a force, normal force, let us suppose acting always perpendicular to this direction. This is the direction of normal I have shown here, and the displacement of the body is always along the perpendicular to it at every point in this direction. So this is the S displacement here. Since work done we have defined as work done we have defined as F S cos theta. This cos theta is what? The cos of angle between this force and displacement. So this angle is 90 degrees, so our work done will be equal to 0. So work done by normal is 0. So this is our third equation. Let me put all these values in the work energy theorem equation that we have calculated earlier. That is what? K final, that means kinetic energy at point Q will be equal to work done by all the forces, that is work done by mg plus work done by this force F plus work done by this normal. Okay, what is the value of this work done by this mg? We are getting here Wmg, that is negative of 4 mg. Okay, So this term is negative 4 mg here, plus the value of this Wf we are getting here 90 Newton, 90 joules. Okay, and this is 0, right? Now we have to put all the values here. What is the value of this mass m? That is 1 kg only. Okay, so here k final value will be equal to, let me put all the values, 4 multiply 1 multiply 10 plus 90 plus 0, that is equal to negative 40 plus 90, that is equal to 50 joules. Okay, so kinetic energy at point Q will be equal to 50 joules here, right? Now equation in the question is given that kinetic energy in terms of some n. So we will be relating this kinetic energy at point Q is equal to 50 joules we are getting, that is equal to n multiply 10. So here 0 will be cancelled out and the value of n we are getting here is 5. So 5 is the correct answer here, that for this question, that value of n we are getting here, that is equal to 5 only. Okay.